Hi there! In this tutorial, we're going to see how to create the baked pivots effect in Godot. Here, I have three examples, one for pushing, one for rotation, and finally, several combining effects like distance to the plane, rotation, and scale. The first example is available for free on my Patreon, and the last two are for my supporters. First of all, the concept of UVs needs to be clear. The coordinates of the UVs are linked to the vertices of the mesh. If I move the vertices, the coordinates move with them. Only when I directly manipulate the UVs, for example, in Blender's UV editor, do they change their position in relation to the mesh. In this model, you can notice that in some cases I reduce the coordinates to 0 to obtain a flat color. I only reduce to align the UVs to represent a gradient, but here in the color of the frame, you can notice that all the faces point to the same UV coordinates, so I can change the color of all faces at the same time. Reviewing the previous concepts, I can map 3D coordinates in local space to normalize it to the coordinates in the range 0 to 1. In another case, I can map multiple 3D coordinates to the same UV coordinate in an n-to-1 relationship. So the question is, how can I map vertex coordinates to UV coordinates in 3D space, creating pivots? Well, the answer is to use two UV maps to obtain the three XYZ coordinates. In the first map, we get the XY coordinates, and in the second UV map, the Z coordinate. These coordinates have the characteristic of grouping several vertices in the same UV coordinate. They are normalized in the range 0 to 1 and are in local space. Of course, there are two maps. Let's start with Blender. First, I load the Godot SVG file, scale the size and convert it to a mesh. Then, I extrude it to give it a volume. I'm going to move the origin to the center of the mesh to be able to center it, and after that I'm going to position it just above the origin of the world. This position is required for the shader that I will use later. Now, I'm going to reduce a little the complexity of the shape using the decimate modifier. I'm going to modify the viewport display to wireframe in order to see the final result. In my opinion, these vertices are enough and cause less problems when creating the pivots and applying the shader. I will convert the mesh again. Now, I will resize the model to create a fracture effect so that the gaps are not so noticeable. So I will go to Object, Quick Effects, Self Fracture. And now I'm going to delete the original model, and I already have the pieces I am going to get the pivots from. I just check that the effect is correct. I am also going to merge the vertices because this effect splits some vertices and that creates a lot of problems in the shader. You can see how many vertices were removed. I also check the normals. If all is blue, everything is okay. Finally, I select all the objects and press Ctrl G to join them into one mesh. Now I'm going to reduce again to the original size to reduce also the spaces, and I recenter the mesh and put it right over the origin. I have the habit to always apply the transformations. Sometimes I forget it, and that causes horrible effects when exporting to Godot. Now I will go to the UV editing tab, then I switch to the front view by pressing the 1 key on the numpad. And I am going to select UV, Project from View, Bounds. Then I will go to Pivots, Individual Origins, and I am going to press S and 0 to reduce the scale to 0. Now in this UV Maps panel you can create different UV maps. Here I am using the default, but I need a second one. So I am going to add it, and I am going to select the icon on the right to make it active. Now I select the right view and use again Project from View Bounds to generate the Z coordinate in the second UV map. I reduce the coordinates to 0 using individual origins. And now I have the pivots that I can use in my Godot shader. It only remains to export in GLTF format and put a representative name. I select Export Selected Objects, and that's it. Now in Godot, I will import my GLB model and put it in the scene and then make local and put it under the hierarchy of the root node and rename it. Now I am going to apply a material shader in the material override. I will call the shader BK pivots. Now I am going to copy the shader I already made and explain it in detail. I am going to save the scene, and also I am going to apply the script required to pass the coordinates of the object that modifies the effect. I create a marker 3D node and I call it effector. I reload the scene and I adjust the colors, and you can see that the effect works correctly. The effector pushes the mesh pieces using the pivots. So let's review the GDScript file, which consists of a few lines. Here I am sending the dimensions of the bounding box to the shader. This information is important because we have to multiply the normalized UV coordinates by these dimensions to obtain the final coordinates of the pivots. And finally, I send the global position of the effector. Now in the shader, I work with world vertex chords because it's easier to work with. And next, in this section, I get the pivots of the 2D coordinates that you will see is a tricky operation. Previously in Blender, I projected the UV coordinates in the front view and also in the right side view. The final goal is to get the pivot points of each piece of the mesh geometry, as you can see here. To do this, I have to make some adjustments to the UV coordinates. First, I need to move UV1 to the left because the model is entered in local space and this is not reflected in the UV projection. Next, I have to invert the Y coordinate of the UV. This is because Godot's UV coordinates are inverted. If you think about it, this has no effect on regular UV maps, where the UV coordinates are not in 3D space. In this case, it does matter. Now, I have to invert the Z coordinate and move it forward. This is because Godot coordinates are different from Blender coordinates. The Z coordinate, which corresponds to the Y coordinate in Blender, is inverted. Although the order of the axes doesn't really matter, since we are not capturing local coordinates, only UV coordinates. You also have to understand that this was a trial and error process. But I think that if you follow the same procedure that I did in Blender, this works for any type of mesh, since the code to adjust the UV doesn't change. So here is the code that I mentioned above that makes the adjustments to the two UV maps to convert them to 3D coordinates in local space. The next step is to convert these local coordinates to world coordinates using the model matrix. Using the vector that goes from the effector object to the pivot point, I get the distance and the direction to modify the vertices, which are clustered in groups. Now, this drawing represents the pieces of the mesh and the vertices that compose it. This vector is the subtraction of the pivot point minus the position of the effector. I use this vector f to apply a displacement to each of the vertices. In this way, I obtain a uniform and group movement of the vertices with respect to their pivot, which is defined in the two UV maps. But I am not just limited to displacement. I can also rotate and scale the vertices with respect to the pivot. That's why this technique is quite useful. Now, I am going to smooth and normalize the proximity effect, which is a mask that I am going to show you next. This mask drives the deformation of the vertices. If I remove the smooth strip function, you will notice that the mask becomes hard to manage, as you can see. Now, by finally applying the proximity mask plus the color and emission string variables, you can now see the final effect. In my opinion, it looks really cool. As I mentioned before, there are two additional examples for my supporters on Patreon. The first one contains rotation, and the last one contains several effects such as distance to the plane, rotation, scale, as well as an easing curve to control the effect. It also has the additional effect of offset pivots, which moves the pivots randomly, making the rotations more chaotic and a bit more organic.